Welcome to the Clay Fab Lab. This is the first iteration of this, and this is an ongoing 3-year project. My name is Shoji Sataki, and I teach at West Virginia University, and one of the co-coordinators of this project with Andy Brayman. And thanks for coming. And like I said this morning, we are looking for your guys' feedback. And so we want to continue to make this better, and we will be doing another, like a 2.0 version in Portland. And so I just want to let you know, please have your cell phone on buzzer or silent, right, on vibrate so that it doesn't ring. And I also want to mention that we are live streaming the today and tomorrow on the 92nd Street YMCA virtual clay site. And it's right there. And so, and it's been actually working out really well. And so if you can't come to the room, you can still downstream it. You can actually live stream it. So, and I want to introduce to you our speaker, our presenter today, and his name is Bryan Czibesz. He got his undergraduate degree from Humboldt State and got his MFA degree from San Diego State University with Richard Burkett, and they did their demonstration earlier today. Richard, are you here? Okay, there he is. So it was fantastic, and that was one of the first things we did this morning. And please come by tomorrow because there'll be a lot more presentations and speakers and demonstrations as well. So. And Bryan also teaches at SUNY New Paltz. And then in his busy schedule, he spends a lot of time just sitting across the country building these printers for other people. And in fact, we had him just out at West Virginia University a couple weeks ago building two of these printers. So and he has an extensive website. And a lot of this stuff is online, and he'll tell you all about it. So.
Oh, I think I'm good. Thank you, Shoji. Actually, I want to thank a bunch of people right now before I get started. So Shoji Satake and Andy Brayman for thinking through this and getting it organized. I'm really looking forward to tomorrow and 2.0 in Portland and 3.0 wherever that's going to be next, the year after. So it's really exciting, and I think the time has come for us to to get to know these tools and to think about what they can and can't do, which is exactly why we're here. I also wanted to thank a couple other people who helped to make this part of the demo possible. Richard Burkett, who obviously I was demonstrating with, but also my MFA grad, Sarah Heitmeyer, our post-bac student, Kevin Saplinsky, who's here, who helped to assist mostly in preparing clay and getting stuff organized when I couldn't do that yesterday. And my partner, Jessica Brandel, who provided one of the 3D printers here and has done a lot of speaking and advocating. Even today was doing some demonstration as part of what was going on. And K-State, Kansas State, which is the source of the other printer, they provided that. They brought that from Manhattan, Kansas, which is actually sort of a testament to the sort of community that's helping to bring a lot of these resources together, which I'll talk about a little bit more in a second. So thank you, everybody. I'm going to talk about a couple of things, and it's all related basically to what you see here. And I spent plenty of time talking about the specifics of how the machines operate, but I wanted to put that in a little bit of context. And so even though this is about the 3D printers and about experimentation and collaboration, I did want to explain how I got to this point a little bit, like the things that I think about in my research and in the work that I've made, and then how that kind of relates to experimentation and collaboration, because that's really how this happened. I'm the kind of person who is a tinkerer, but I'm also the kind of person who, it turns out, I didn't really realize, who likes to collaborate. And even though a lot of times my work seems like it's a kind of perfect end result of a plan, it's not really like that. So hopefully that will come through in the presentation. These are a few of the things that I'll talk about. I have this slide just as a kind of overview of the resources, but also the points that I wanted to hit. Some really important things, including the people who are part of the legacy of where these printers came from, some things that are current happening in the field specifically with extrusion, ceramic 3D printing, and then a few entry points into getting yourself past a kind of digital threshold to the point where you have some models to work with. And I'll talk about all those things a little bit as we go along. So, the grounding point for my work is related to the body, and I think a lot of us maybe have that as a grounding point. Maybe not exactly how I think about it, but clay is a very tactile material, and our body engages with it very specifically and very directly. But like Andy Brayman was talking about earlier, the body is an unbelievably beautiful and complex system that we don't really understand that well. And so actually my entry point into making work was kind of trying to put together a really fussy visual language that for me was hoping to capture a kind of intense attempt at engineering something that isn't so engineerable. And so this work for me is about fragility and a kind of like impassioned attempt at trying to figure out what the body is like. And we do this in a lot of ways. We think about the complex systems, for example, how we're able to see what the pathway to the visual cortex is like. And we understand it to a certain extent, but it's a system that's so beautifully complex that it's really difficult to simulate. And so my work has been engaging in object form these kinds of questions. And in some cases, it's taken the form of mechanical configurations. So I started thinking that the body could look like a mechanical system, but that was a sort of reduction down to maybe one element, like the extension of a foot simulating a leg that provides a kind of porcelain fragility when it's extended fully. Technology also relates to the body in this way, which is that we have these complex internal systems that are functioning, but we're not entirely involved with those processes consciously. And furthermore, we can't see them. So we have to invent technologies to look inside of the stuff that we carry around with us all the time. That is infinitely fascinating to me. Sometimes I spend entire days unable to get past the threshold of understanding that because I am a system. I'm a walking system, and I'm not necessarily in total control of it. The way I think about it, I'm in control of other things in the physical world. So I've made work that has a response to that, and this was the first place where I started thinking about having my work be not just a mechanical construction or configuration, but that the machines that we have available could be involved in making the work or making part of the work. So referencing ways of looking through the body and looking into the body, I was using a CNC machine to cut low temperature bisque porcelain tiles. Which was the result of some tinkering that if you ever have the opportunity to do, it's not particularly good for the CNC machines, but I was cutting clay directly and making these lithophanes from digital models and thinking about the role that the machine might play in helping to facilitate the production of the work. But to get back to the sort of the question of technology, technology and the body are certainly related to each other. And I think about technology as a way of us transcending our physiological limitations. But when we look at it in I guess, a sort of a broader context, it's actually the sum of a lot of things. There has been, over the course of all of the generations and all of the sort of previous species of humanity, there has been an accumulation of an understanding of our physical existence in the world. And this is really what technology is about. Technology is about understanding that we exist as a physical being, and there are things that we want to do. We want to maintain our bodies, and we want to maintain relationships both with each other and with our environment. And this is exactly the impetus for inventing technologies, for understanding how materials work. And so it's embedded so deeply in who we are as people. It's really difficult to talk about technology without talking about a really huge continuum. And working in clay is actually a really beautiful way to do that because it describes a continuum across time that has been relatively continuous. And it's a material that anthropologists actually define certain eras based on our relationship to material, right? We talk about the stone, and various ways of manipulating metal as defined stages of humanity. We don't talk about ceramics so much because it's actually so pervasive. It's sort of at the foundation of who we are. Speaking of foundations, I spent some time in my work trying to figure out what the foundation of technology was. And so as I was imagining the body as this thing that is only so fit, it's only so strong, and it's a limitation that maybe we want to transcend, I got to this idea, which is the idea of the way we achieve mechanical advantage over things in our environment. So the 6 simple machines are kind of a six-fold key to understanding how we can move things that are heavy, or to actually then synthesize these methods and construct machines to do tasks. So this project was my attempt to both think about that as a really basic and fundamental kind of dumb technology, but sort of exercise the most complex way of understanding it that I could at the moment. So I started by hand constructing these formations of the six simple machines, and then I put them through a digital process that involved scanning and then reproducing. So the object existed as a sort of immediate prototype. I spent 15 minutes maybe rendering these objects, right? So they're very sort of loosely made, and they're showing the mark of my hand. And then through the digital process, they become something else. But then the digital is a material that kind of has no scale. It's its own material, but then when it's output, it can be anything. So I was asking questions about what the output could be. There's a temporary machinable wax prototyping material, and then it becomes permanent again. And for me, this was an exercise in trying to understand sources and a kind of authenticity. It's a bit of a kind of Platonic question, or like the question that Joseph Kosuth was asking in terms of language, which is the original the point of authority in this progression? And is that the most understandable manifestation of it? Is it when it's in the digital space? Is it when it becomes physical again in this form, or in some other form when it becomes permanent? And the language, the dialogue across that. But I wasn't so satisfied with that process, and I realized that it's sort of a bit of a trope, and I think I fell into it, which was if I got to this point in this work, and I realized that I had lost my relationship to the hand. I was simulating my hand over top, or having the machine simulate the marks that my hand had made. But when I got to the end, I was dissatisfied. So I decided to make it big and to make it by hand again. And so these are sort of an attempt to make icons again out of the starting point. And I was kind of resimulating both the mark of my original hand and the mark of the machine, but at a different scale, which involved a different relationship that my body had to the work. So then the idea of collaboration came up. And I was presented with a project that I hatched with Sean Spangler. And our first collaboration was a further investigation of this idea of authorship. And we started with a couple of historical objects, and then decided to see what role digital processes could play in remaking them. You know, across all of ceramic history, we have looked at forms, and it has been a kind of continuum, and the sort of the point of authority of something from the Song dynasty is really difficult to pinpoint, right? Because there were antecedents to that. And this is something that has happened through art making, in particular with ceramic vessels, for a really long time. So, you know, we thought about establishing a few benchmarks and then figuring out whether there was the ability to be authentic to that starting point, or whether there were new things that could develop that then could become their own thing. And it was a bit of a futile exercise. I mean, the first thing that I did was I asked questions about resolution to see whether it was possible that these objects could kind of become one if I reduced the information. But I stopped that exercise, and we just played. And we played by using scanning methods for these objects and reproducing them by prototyping them in foam and in plastic, by slip casting, hand building, throwing, and doing every possible way of re-looking and remaking the objects that we could. And we thought about them as a kind of genealogical construction. So the shadows here are the shadows that point most closely to the original objects or to the historical starting points, and then the rest of the objects kind of come from that. But the thing that was challenging about this was that we really wanted to collaborate on a core level which was different from what we were doing. It was sort of like a telephone game. I would make an object, and then Sean would make a response to it, and then we would sort of continue down the line. But we asked the question, what would happen if we were working on the same objects? And is there some new way to do that? Could we sort of conjure a new way to be able to collaborate on that core level? And that's actually the genesis of this 3D printing. I mean, I had a CNC machine in my studio for a long time, and I was prototyping things. But even with that, I was dissatisfied with the output of the mechanization in foam or in plastic or whatever else I was cutting. So this project, we had Sean and I had a kind of similar starting point where we started with these historical objects, and then we thought about every possible way that we could reimagine them. And the first way that we did was through a scanning process, we reproduced them as faithfully as we could, and decided to push the reproduction to a kind of logical conclusion for us, which was that the surface would be so refined that the object would kind of disappear. It would actually become a shadow in and of itself because this chromed surface is so reflective that you don't see the object. When you look at the object, you only see the environment around it. So that kind of let us have a portal maybe into the rest of the work, at which point then we just played, and we made hundreds of these objects, which were at times referencing parts of one form and parts of another, at times referencing the things that I have done in my studio practice and things that Sean had done in his studio practice. And the end results were a little far afield, I guess, from our starting points. And you can see some of this work at the Nelson Atkins and at ArtStream 2.0. And these are collaboration at a core level. So these 3D printers, when I talk about the DIY thing, I'll explain this a little more, but these 3D printers are extruding clay, and the clay can be any smooth clay that has just a slightly higher water content. This is essentially the same clay that Sean would use throwing on the wheel that we would use for hand building. And it opens up a way of working that seemed much more familiar to us because we're ceramic artists, and we have a range of tools that we use in the studio, and the thing that came off the 3D printer is something just like what would come out of the extruder or a slip cast object or something that was thrown or hand built some other way, and we can join them together and then engage a dialogue across the rest of the ceramic processes that we were familiar with. And so it was a way to promote some familiarity, and I'm still interested in the potential from this. I think this collaboration actually will continue. Sean and I have another show in the works, and so we'll see what comes. But also in collaboration, I worked on a project with Jessica Brandel. I actually should have a shout out to NCICA. The International Residency Program, Jessica, Brandel, and I were the recipients of the year before last, and then the summer before, this past summer. Wait a minute, I'm thinking of it wrong. Yeah, this past summer, we went to Italy to the residency Creta Rome, and the impetus for this was a discovery that Jessica had made that really kind of captured our imagination. So you imagine we're in Italy. And thinking about this place. So it's a kind of like the quintessential moment, the arresting of humanity. It's preserved under this fog of sediment that preserved history in this moment. It's a really beautiful snapshot. And the plaster casts that came from bodies that were actually there protecting their resources, thinking that the eruption was going to subside. They actually ended up perishing because they were trying to protect their homes and their goods. They really, kind of sparked the imagination about humanity lost. But there was a discovery a few summers ago by a French team, and I guess you all probably know this, that those of you who are working in clay, you have a legacy much longer than your lifespan. And when we dig sites up from thousands of years ago, the things we primarily find are the most durable things, like ceramics, for example. And so we normally find shards of fired ceramics, but at this particular site in Pompeii, there was a studio workshop, and in addition to the things that were normally found, which were fired examples, there were examples of unfired ceramic, which is not a very common find. You can see this incredibly delicate object here, barely holding itself together, still has the evidence of the terra sigillata on the surface. This is unfired clay from 2,000 years ago. And so Jessica and I were thinking that that these objects never had a chance to achieve their complete life, becoming permanent ceramic objects, and it's sort of a fluke that they were found. So if we could use digital processes to scan them, they could be integrated into the rest of ceramic studio processes, and we could give them a new life. Well, this project is ongoing because these objects we're still working to get our hands on. Interestingly, if it's unfired ceramic, the nation of Italy doesn't treat it as the same kind of artifact as it does fired ceramic. They treat it like soil, which falls under a different kind of category when they're doing excavations, which is actually good because they're under fire from UNESCO for poorly managing their World Heritage Site at Pompeii in the first place. So it might be better. So we're still trying to get access to these objects. But what we ended up doing was another thing that was really motivating for us being there in the first place, which is that Jessica had made contact with a woman who was basically a hired gun on archaeological projects. Her name is Gina Tibbett, and she was in Pompeii doing a reanalysis of some previously excavated objects. So we got there and we got access to these objects that they were working on, even just for an afternoon, to the point where we're holding 2,000-year-old oil lamps and looking inside and seeing the evidence of the fingers in the press molds from when these were made, next to my own fingerprints and Jessica's hands holding them. These objects were actually from a trash pile, from a dump right outside the city. And of course, they were fired ceramic mostly, and they survived. But a lot of them were actually production flaws. So this one was maybe trimmed a little too thick. It might have been cracked. Who knows if it even had a life? It might have just been had been a second, or something was discarded before it even made it to somebody's hands. And so, for example, this object, which was shard PN190, we did a sort of scan and reconstruction and reproduced the object with some terracotta clay, trying to simulate some of the local materials as best we could. Jessica made some terra sigillatas, and we thought we would kind of remake them in a number of ways. We thought about remaking the object that this thing came from originally by our own hands, using a similar mechanized process with a wheel, making it by sort of pinching it by hand, 3D printing the object, remaking the shard itself in every other way that we could imagine, thinking about visualizing it and remaking it and trying to give it a new life and a new understanding. And we made a lot of objects during this time, and a lot of them were the result of processes that we all engage in. So we were focusing on pots, and we were trying to also transcend the idea of the museum vitrine, which is a barrier often to something that we all want to do, which is to kind of reach in and hold these things and understand them in that way. And what we thought the 3D printing process could do was to provide a way to actually handle it, and to handle it in a meaningful way, to actually be able to put our hand back in the work. So we remade a lot, and we were really fascinated by the Etruscan Bucaro objects that we were finding in vitrines, and a bunch of other objects. And we were using the printer to do some drawing processes, thinking about objects, artifacts, fragments, drawing processes. And then this piece, which is currently at Lux in Nebraska. Yes. Well, not actually this piece. This piece is in Italy. This is PN 498, which is a small handled mug that had an S crack in the bottom, and that's probably why it never made it. And so this is, unfortunately, it's kind of blurry. But this is Gina Tibbett holding the piece, and we're able to look through and see that tiny S crack, which is sort of heartening to those of us who work in clay, right? But so it got sort of scanned and I say sort of scanned because we kind of cobbled together our scanning resources because we didn't have a lot of time. But we scanned and then did some remodeling and reproduced the object itself as a fragment, and then thought about ways to give it a new life. And again, this is ongoing because we're still thinking about what the result can be. And I'll talk about this work, and then talk about the printers. So another way that I've been interested in using these processes is a way to mine things that don't exist from my personal family history anymore. So my father was born in Hungary and left as a result of what happened at the end of the Second World War. And so I went to Hungary and used some digital scanning processes, stereophotogrammetry. So this is a Hero Square and some results of a photographic process of making digital 3D models and the reconstruction, and then finally the printed object. And what I'm searching for in this work is trying to kind of harness the language of the printer and thinking about the extrusion process as a drawing process, as a kind of gesture, an object gesture, or gesture in space, as a kind of continuous line, and a searching for form. And the computer thinks, or the printer even, thinks that it's following a really specific code. But I'm tricking it a little bit, and I'm encouraging it to spit more material and to engage in a little some inexact behavior in order to make something that is both precise and imprecise at the same time, in an effort of trying to invent. This is a scan from an object that my father's cousin has, which was a mug that has a handle that was broken, and she was holding it together with some masking tape and refused to glue it back together because she didn't want to disturb what was already disturbed. So I thought about scanning it and reproducing it and giving it a new life. And this is an object that was a scan from a World War II memorial. Two of my father's cousins are memorialized on this who perished in World War II. Second cousins, like my father's parents' age. And the end result is something that is sort of disarming. It's a memorialization of power and might, but it has a looseness and a gesture that is soft. It's almost like a cloak of the original thing. Okay, so where these 3D printers come from is a place that is, again, kind of building on a legacy. You may not be familiar with the RepRap organization, but desktop 3D printers are the result of an open source community who are sharing resources, to the point where they thought that if you could build a 3D printer that could print plastic, why wouldn't you design a printer that could be built from plastic parts that another printer could make? Right? So it's like paying it forward in the way that if you have a printer, you can make parts for a printer for her, and on and on and on. It's like the closest to self-replicating that you can get. And that's at the core of the ethic of the sharing of the open source community. This Google Plus group is a place where you can find a lot of really good information, current information, like what's happening right now about what people are doing in developing paste extrusion processes, primarily ceramics on this site, but basically anything else that you can make a consistency that you can push out, or that you can spin out with an auger, or that you can, like what Keith Simpson is doing, that you can feed out with a gravity feed. It's all these resources are being shared on this website. It's a very active place. It may also be the only place on Google Plus where you might want to go. I mentioned Dries Verbruggen earlier. This was one of the very first Rapman 3D printers that he adapted a syringe, an extrusion cartridge to. And he's really at the front end, was at the front end of adapting clay to 3D printers. It's hard to overstate the role that he's played in getting us to this point. And it's also hard to overstate the role that Jonathan Keep has played. Jonathan Keep took the ideas that Dries was working on and thought, well, if we can make the printer so simple that you can make the parts out of MDF in a wood shop and hold it together with zip ties, then it's going to be easier for other people to get involved in it. And his design is a design that I adapted for these machines, which is what I've been doing as workshops. These are the first two 3D printers that I built before I decided that it was a good idea to kind of help to get involved in democratizing them. So the first one is based on a Cartesian printer, much like the rest of these MakerBot-like machines, and the one on the right was a Delta configuration. So the build kind of goes like this in terms of the workshop. You may start with a pile of parts like this, which I helped to facilitate. This is from the build. You can probably tell from the clouds in the airplane. This is a build from OCAC with Dylan Beck, Oregon College of Arts and Crafts. And then as a group, everyone gets involved, swinging hammers to hammer the structure together, putting the wires together, and getting invested from the ground floor. And it kind of works like this. We'll see if this starts to play. It's playing for you. So this was when I was in Hawaii, building two 3D printers with Sean. And it's really just as simple as this. It's as simple as taking the parts and then making sure that they go together, right? And making sure that the thing is even and square. And clay has a kind of precision which is loose, so it doesn't require a micrometer and really fine adjustments, which is really nice. And so then result are things like this. And then really one of the keys, you can spend a lot of time in the digital space, but one of the keys to really understanding how these printers work is understanding the relationship between the digital 3D model and what the printer is thinking. So this is a video screen grab of a simulation in what is known as a slicer software. Those of you who know 3D printing know this, but you take the model and then you resolve it into slices, and they're layers that the machine can understand. And that's actually where a lot of the invention can come in, and where the tinkering and my interest comes in. Because the machine is thinking about how it's processing the code and trying to understand it in a really particular way. And you can be in control of that. You can be in control of the resolution, like how many slices it's simulating, how wide the various shells are. And you can also control how fast the machine is working. So there's a lot of flexibility in that, and there's a lot of invention that can come in that part of the process. I like to include this as an end result of the workshop process, which is when you get the thing built. Even the old guard, Richard Burkett, will take a selfie with the machine. Okay, so just quickly, a few things that you probably have not seen, and there's a few more slides, and then I'm done. So you may not be familiar with a couple of things. Those of you who were here earlier, Richard Burkett was talking about David Harold, and these are the images of who I like to refer to as the grandfather of extrusion-based ceramic 3D printing. He built this machine in the 1980s, and it's an analog 3D printer. It's this beautiful thing that is cogs and a processor, like a spirograph processing base that builds shapes and forms. And then ratchets up layer by layer, and he was pushing the clay slip out with the lever on the right. So you can see the structure that's kind of processing, and then the way the material comes out at the top. And I promise to tell this joke again, but this is the kind of like getting back to the soul of 3D printing that you might see come out of Williamsburg, Brooklyn these days. You know, somebody with a beard who just really wants to be real about 3D printing. And it's true, right? I mean, this is really simple technology, and at its core, it's understandable just like this, and it's exactly what the machine is simulating and is doing in a mechanized way. Dries Verbruggen with Unfold has done an unbelievable amount of work with this process, and has been thinking about it for years in a really complex way. And one of the really interesting projects that has made its rounds even to the exhibition Out of Hand at the Mad Museum was this, which is a project that he did with Tim Knappen, a programmer, which was the idea of simulating what a throwing process might be and then allowing machines to reproduce the work, which is a question that I think we're all asking. It's sort of like the elephant in the room. Like the first question on everyone's mind is, what will happen to the role of the hand in the process? And so Dries was asking the question of, if you built an environment that would allow you to simulate with the motion of your hand the construction of the form, what would the output look like? And I think, over the course of the various installations, the kinds of forms that came out of this were quite interesting, but they were also kind of exactly like the way every other first processes go, like the first time you sit down at the potter's wheel. Right? There's a sort of elegant inelegance to this and a kind of naivete to it that I think is suggesting that this technology is a lot like every other technology. And it's something that we're trying to figure out what its role can be and how we can understand it and to make it meaningful. Jonathan Keep, just one example of the work that he's done, is a way of allowing the machine and a number of digital processes to simulate the kind of stratigraphy of things that we can't see. So this work actually is a simulation of iceberg forms that he's actually using sound to help to formalize. And the end result is referencing, of course, the kind of icy transparency of the original source. And then two other examples of some things that are going on. I wanted to mention the work that Jessica Brandel has been doing, which is building on the 3D printer that she constructed and the work that we have done among all the other interests that she's had in her studio practice, which is grounded in image making and sgraffito processes. And so she can even be working on top of those ways that she has worked in the past with some 3D printed parts. and can also be excavating things that you all also have as a resource. So that Morphosource site that I mentioned in the beginning is a place that Duke University has put together, and it's a place where you can go and find anthropological data and download digital 3D models for free. Excavated hominid skulls and body parts that you sort of think about as the legacy of humanity that people are digging up. They've been digitizing this information for years, and it's available. And you can do things like reproduce hominid skulls and understand them in new ways. And I'll mention Brett for a second, or friend, I should say, because Brett's work is integrating the use of extrusion ceramic 3D printing processes, but not exactly the way even that we're thinking about them. And he has done some work. He has one of, I think, the Potterbot machines. And he's been extruding, making these objects, which are referencing objects that he's already existed to try to understand what they were like. And he's gotten to the point where he's thinking about the language of it just as a visual language, not so much as the output. And he's slip casting parts of them. All right, so this is, this sort of like the next step, like what happens when you do that. So there's just a couple examples of other ways of working that are really interesting to me. But I'll end on this last thing, which is that technology is an extension of our goals, our interests, and our needs as humans. We invent these tools not to necessarily or to directly confront ourselves with a sort of existential problem of what our viability is. That the mechanized tool should not be something that we feel threatened by, or that our hands should feel threatened by, because they're an extension of our bodies. So the things that we want these kinds of tools. We want to figure out ways to transcend what we can do with our bare faculties. We want to figure out what those things are. It doesn't mean that we don't want to engage in these kinds of processes. And I think working in clay, and with these extrusion 3D printers in particular, it helps to keep that door entirely open. And it helps to keep us understanding part of what keeps us grounded in working in clay in the first place, which is its directness and its tactility. But it opens the door to every other way of working, which I think is exactly what technology is about. And even though we live in a hyper-digital culture even, we still physically exist in the world, and I think clay is a really beautiful material to help us to continue to understand that and to understand our goals and needs. So that's what I have. Thank you all. Anybody have any questions? We're getting to the end of the day. This is like the wrap-up.
So I was just wondering, like, what kind of front-end investment, if you're interested in kind of making your own, like where you're talking about to a certain extent, you're making a ceramic one, you can't really print your own parts.
Right, in terms of the RepRap ethic. Yeah, so my design, kind of supposes that you have access to a plastic 3D printer, and increasingly, so there are so many of those that they're pretty accessible, like at public libraries, right, which is incredible. So I mean, there is that limitation, and so I think the output of this, even though this is kind of like a RepRap machine, it is not exactly that, because the things that come out of it, I wouldn't want to build a 3D printer necessarily out of the objects that come out of my printers. Although I'm interested in exploring that. That could be a good thing. So the construction does require some tools to be able to build it, but they're still really accessible. Yeah, and again, if you're interested in this build or Jonathan Keep's build, you can go to Jonathan's website, you can go to my website, and you can look me up on Thingiverse and Instagram, and you can find ways to get the resources. And about resources, I will say that none of this is proprietary. It's all free and open. And so all the digital models for the parts and a parts list and everything is all available. And if you look on my card, you'll see those resources. So I've also been in the habit of sharing the digital models that I've been working with as a way to help to facilitate transcending that digital divide, because digital is a very complex material.
Are the plans for being easily scalable?
Yeah.
Based off that, could you make one twice as big without too much?
Yeah, one of the things that I could have mentioned that I took out of the presentation was this group in Italy called the WASP project, and then actually a number of organizations in China who are using this delta configuration in particular to scale. So if you look at the structure as those metal rods, and if you make the base wider and make the metal rods longer, the machine is very easily scaled. And it's scaled at a cost which is a little reduced compared to something like what Keith's machine is, because that's dependent on those extruded aluminum parts, which are a little more expensive. So it's a little cheaper to scale these kinds of things. And then you just have to know enough about how to manage the firmware inside the Arduino module to calculate the dimensions. And that's really it. That's all it takes. You know, past a certain point, you need more amperage with the motors and stuff like that. But I guess that's sort of understood. But yeah, you should. I mean, the WASP people have one that's 12 meters.
I think I saw that
Yeah,
online when I was
yeah, it's pretty amazing.
Things improving. It seems as though the resolution is not where it's ever going to compete with the work that
Yeah.
people use functionally.
Yeah, I mean, so this is a perfect opportunity, since Greg's over here, to really explain the sort of goals, the end result goals. So the things I'm talking about and sort of advocating of the directness in the material that comes out is at the expense of resolution, right? If you're extruding plastic clay, you cannot achieve the careful exacting detail that the machines that Tithon are working with. So if what you want is that kind of precision and resolution, and if you're really crafting in the digital environment and you really need a faithful reproduction, there are better tools for that. This is a tool that has some limitations in terms of its resolution, but it has the other benefits, right? So the tool also is something that you would choose based on your end goal. Does that make sense? Yeah.
I really agree with that. Like, I always ask people to consider what their goal of 3D printing is before you get into a printer. And like, I've recommended Bryan Czibesz's workshop to countless people because their goal met his program better than it met mine. It's very, very much like, ask yourself, what are you trying to do with it? Like, what's your goal? You want it to work with different materials, but it's like so much of trying to figure out what you want out of the 3D printer and making that work for you. Because if you're just going at a 3D printer, you're probably not going to be satisfied with the result, whether it's mine or his. Like, if you don't have that goal in mind.
Yeah, actually, to that end, I was going to say that that there are plans for a DIY version of a powder-based printer. Where you take like an HP print head and you sort of similar to the way a lot of these printers work, and you can cobble one together out of laser cut acrylic and stuff like that. But I stopped. Like I started going down that road, and I thought, the other people are doing this a lot better, and I'm going to focus my efforts on something else right now because there was too much to invent there, and there's so much good work being done in that was important for me to focus on other places. Eddie, did you have a question? Yeah.
It's more of a common desk. Like, instead of just thinking about the 3D print as being like a final product, just think about that's what you got, right? Like, manipulate that print to be smoother, like, find that print.
Yeah.
Do that in the plastic world. I mean, I have more experience
Right.
with plastic 3D printers. They'll use fumes and other things for smoothing out of the edges. And I haven't seen people trying to, at least I don't know, using a rib on this kind of material.
Yeah, well, that's an interesting question. I mean, I think, I'm not exactly past the point where I'm done understanding the resolution of the print. So even though there's some reconstruction, I'm still thinking about that stratigraphy as a visual language, which is really distinct to the process. But there are a number of ways that I started to transcend that. You see some examples over there of some of the really sort of finely and carefully extruded. As soon as there's a thin layer of glaze, that stratigraphy goes away. So there are some strategies, right? Sort of like what you can do with plastics to get rid of those marks of the resolution. But yeah, you can smooth it out, you can incise it, you can do all of these things. Yeah, because it's just clay. It's easy for me to that's sort of like my trump card. I just say that. It's just clay, right? Right? Any other questions? Great. Well, thank you, everyone. I really appreciate it. It was a great day. And be sure to come back tomorrow because we only got through half of the demonstrations of the tools and the processes that are going on here. So, thank you all.